All right, folks, let's go over this one here. Hopefully you had a chance to look at it. All right, so again, a literal equation. Literal equations have a bunch of variables in them, right? And they kind of start complicated and they kind of stay complicated, right? We don't ever really get to simplify a whole bunch. They just kind of stay messy. But that's okay. We can still, do this. So, I mean, here we're trying to get that h by itself. All right. So let's see here. So Kendall, were you able to? What was your first kind of inkling here? What did you try to do to both sides here to get that h by itself? You didn't know? Okay. Well, let's take a look here. So we've got 1/3 times pi times r squared times h. So if we see a bunch of multiplication, Kendall, how can we undo multiplication? What do we normally use? Division. All right. So we're going to divide. We're going to divide by all this other stuff that's in front of that h. So we're going to divide both sides by 1/3, by a pi, and by an r squared. And we'll do it over here. 1/3 pi and r squared. Okay, just like that. 1/3 divided by 1/3 cancels. Pi divided by pi cancels. R squared divided by r squared cancels. That's right. So we have h equals v over 1/3 pi r squared. Okay. And this is an answer. You can stop here. You can say, okay, I solved for h. I'm done with the question asked. Now, I'm going to say, though, that if this was like a multiple choice question, most multiple choice answers, or most likely, your multiple choice answer won't have this 1/3 in it because it's a fraction within like a bigger fraction, inside a bigger fraction. And typically we don't do that. Okay? But we can fix that. Instead of dividing by 1/3, we can multiply it by the reciprocal of 1/3. What's the reciprocal of 1/3? 3. So instead of dividing by 1/3, we'll say this is going to be 3 on top, v, and then pi r squared, just like that. Okay? So we can take that 1/3, which we're dividing by, and instead multiply by its reciprocal 3 up on top, just like that. Okay? And this is probably the best answer right here. All right. Questions on any of that? Okay, let's try another one then. We'll go through this one together, okay? This one's a bit newer. Let's say we're going to solve for, I think I'm going to use the letter B here. Okay, we're going to solve for B, and here's our equation. A equals 2 times A plus B. Okay. We want to solve for B. A equals 2 times A plus B. Okay. So there's our B that we're trying to solve for right in there. Okay, there's our B we're trying to solve for right in there. We have some things we have to get rid of outside of it. Okay. So, let's see here. Dylan, do you have an idea about what we could do first here, maybe? Okay, so I heard you say, so multiply, and you want to do 2 times the A and 2 times the B like that? Yeah. Distribute? Okay, yeah, we can do that if you want to. That's one option. Okay, again, remember, we're trying to get that B by itself. Okay? So, let's go to someone else then. Dylan, we'll start with that. Okay, so from here, Tyler C. Again, we want to solve for that B, right? So Tyler, what else can we do now to start solving for B, to get that B by itself? Okay, subtract the 2A? Yes. Okay, yeah, so make sure we subtract 2A. Okay, those are gone. Now, Tyler, are capital A and minus 2 lowercase a, are those like terms? No, yeah, we're going to have to keep, I know it's kind of weird, we got like 2 different kinds of A in there, but they're not the same, right? One's capital, one's lowercase, so we're going to keep them different. And then, Tyler, what's still left over on the right-hand side here? To be. Or not to be. Okay.
No one? Shakespeare, there we go. Okay, that's right. Okay, very good. And then let's go to someone who's here. There we go. Oh, I'm not gonna, let's see, I gotta pick a song. Oh, there, Liv. All right, so Liv, at this point, we want to solve for B. Danny and Mark. Listen up, guys. What's that? Divide by 2.
Wait, isn't that A minus 2A?
It is. But you'll notice one's a capital A and one's a lowercase a. So we want to treat them as different variables right now. But I like what you're thinking, Carson. You're like, wait a minute, those may be like terms. But since one's capital, one's lowercase, we probably should treat them differently. Okay, so here's one way that you could be done. You could say, aha, we're done. B, solved. That's it. Okay. But we can break up this fraction and make it a over 2 minus 2a over 2. Okay, you see how we broke it up? A over that denominator minus 2a over that denominator.
Which one do you want to get more for the test?
Well, you need to be, here's what I'll say. If it comes to, so, let me go this way. If I just give you this problem, and you just have like white space, you know what I'm saying? You can, as long as you get B by itself, you'd answer the question, right? However, if it's multiple choice, you might have to pick more than one right answer sometimes, and you should be comfortable with identifying both. So bigger picture question here, Liv. Always answer the question that's being asked, right? But be comfortable with doing, the both representations and stuff. Good question, though. Yeah. So on tomorrow's mini quiz, probably what you're most worried about right now, right? It'll be white space. So as long as you're answering the question, as long as you are getting the B by itself correctly, you're done. So you can stop right there and say, check, move on. That being said, though, I want to give you guys, your money's worth here. Now that we've broken that up, okay, Reagan, is there any simplification I can do here with A divided by 2? Can we simplify it all?
No.
No, because who knows what A is, right? But 2A divided by 2, can we simplify that?
Yeah.
Yes, what can cancel? What divides?
What do you mean?
What simplifies here? Like what can cancel out? So A, we can't.
Divided by 2
Yeah,
cancel out.
there you go. The 2 and the 2 cancel exactly right. And so we're
Sorry, I
left.
understand what you mean.
That's okay. Sometimes I ask the questions in a weird way, and that's good. You let me know if you don't understand it, okay? So we could also say that's our final answer too. Okay? So either one of these is okay. Okay? This one looks a little bit nicer. It does simplify down a little more. This one maybe looks a little more, scary with the big fraction bar divided by 2. Your choice, though. Either one's right. Okay? Either one's right there. All right, let's see here. I'm going to give you another one. Let's do, I'll have you guys try one more, and then we'll move into inequalities, okay? So this one is one more for you to try here. I'm going to have you do 2x plus 8y equals 16, and I want you to solve for x. Okay, solve that one for x. Okay, so write it down. Get the x by itself. Okay, show your work, please. See what you can come up with here. If you get stuck, let me know. This one K through 2. We'll run around and help you.
So you want to get the x by itself.
Oh, no.
So what's with the x that you need to get rid of? So you could divide everything by 2, but if you're going to do that, you have to divide everything here by 2 and everything here by 2. So the 8 is divided by 2 as well.
Now, that's divided by 2 equals this.
Yes, and remember you can then break up that 16. So it's 16 divided by 2 minus 8y divided by 2. So you can make it 8 minus 2.
Go. Let's say 1 half.
See what I'm saying? Yeah. Yeah, you got it, Scott. Good job. So, okay, so you're kind of on the right track here too. And the only thing is, these are not light. These are 16 minus 2x. Okay? Because they don't have an x here. So we're going to rewrite it. Now, if you want to continue this way, okay, so it means everything here is divided by 2. So 2x divided by 2 is going to be just an x, right? And then 8y divided by 2, what's 8 divided by 2? Equals or wrong? Now finish off x. What else we need to get rid of? So the x, y, z. So how do you get rid of the 4y? Subtract the y equals 7. For y. So we're going to be minus 4y over 2. Okay, yes.
No, but we can't subtract these, because this is an 8x. So it's just gonna be 16 minus.
So
They're not like terms. So
you
just
have
gonna
an
bring
x
them
here,
back.
and it looks like you divide both sides by x plus 4y. But it's like,
Okay, now, how are we gonna get rid of the?
oh, I see what you're saying. So you did everything by 2 first, then you need to divide this side by 2 as well. Like
Then you get,
yeah, you get so hang on.
You wanna get rid of that?
So you divided
Yes,
this side by 2.
That's by 2. Go a line under that
Okay.
whole other side.
What else do you do here to get the x by itself?
Whole side by 2. Now, these cross themselves out.
You want
So let's x it.
it's plus 4y. How do you get rid of plus 4y? Minus, which would
x minus y, then that
Now,
would
let's think about this. Is
if you
equal to
subtract
this, right?
4y from both sides,
Just
that
2 go
4y
into
goes
16
away.
disappears. It's even if 2 goes
If you
into
subtract
16.
4y, that 4y goes away, but with x.
So it's 2 and 16.
Alright folks, here we go. Let's take a look. Now, there's more than one way to do this, and I'm going to try and go over both here just because it's helpful to see. Okay? 2x plus 8y equals 16. Okay? So, how many people here started by subtracting 8y on both sides? Okay, so this is one way to do it. You can start by subtracting 8y on both sides. Okay, you're left with 2x equals 16 minus 8y. Okay, this is for some of you, right? Some of you subtracted 8y first. All right, so then once you did that, Danny, what'd you do from the next step here? To get the x by itself, what was the last step?
divided by 2.
Very good, sir. Divide by 2. That gets divided by 2, and that gets divided by 2. And so both of these numbers are divided by 2 because it's all over 2. And so it's 8 minus 4y, like that. For your final answer. Now, that's what some people did. Other people took this 2x plus 8y equal to 16. Okay. Reagan, what'd you do for your first step?
Like in the beginning, okay,
Yep.
so I divided by 2 on both sides.
Okay, so now Reagan divided by 2 on both sides first, okay, which is kind of strange to us. It may be uncomfortable, right? And it goes against some things that our algebra teachers have taught us in the past. You know, we're like, oh, always subtract that 8y first and then divide by 2. But you can, if you want, start out with dividing here. Here's what the difference is going to be, though, right? When you divide or multiply an equation, you have to multiply the entire side or divide the entire side. So when Reagan said divide by 2, she's not just going to divide this x by 2. She can't. You're not allowed to do that. You have to divide both things by 2, and then you divide this side by 2 as well to balance it out. Okay? So every term on the left side gets divided by 2. Every term on the right side gets divided by 2. When Reagan did that, Reagan, what'd you end up with after the dividing by 2? What'd you get?
Then I brought down x plus 4y equals 8.
Okay, x plus 4 equals 8.
And then I subtracted 4 on both sides.
Subtracted 4,
4y.
4y. Yeah, don't forget that variable. It's part of it, okay? So the 4y's cancel. We're left with x equals, and then our 8 and minus 4y like terms?
4y.
Are 8 and minus 4y like terms? That was my question.
Sorry.
That's okay.
They're not, right? And so we can't put them together. We just leave it as 8 minus 4y. You can see we get the same thing either way. Okay, same thing either way. Which we better, right? We better get the same answer. So, all right, questions on any of that? So we're going to get into a little bit of inequalities right now, okay? I wanted to kind of like just show this a little bit more. Tomorrow, again, mini quiz at the start of class. 3 questions where you'll get, 3 equations to solve for particular variables, okay? So heads up there. We might do one for the warm-up too, just so that way we have a little bit more review before we go. All right, that being said then, let's also, I'm going to pass out some inequalities practice, and we'll just do a little bit of review of inequalities, okay? So let me pass out the practice. Or actually, Ms. Mulcahy, would you mind passing that around? Okay, very good. Let's see.
Ms. Mulcahy, I'll pass that one to you.
You're gonna pass out
There
with
you go.
me? Oh, thank you.
Oh, wait. There you go. Okay. Yes, now just multiply the worksheets, Ms. Mulcahy.
That's right.
This is math class.
I'm
Just
not-
perform a miracle.
not that magic.
Yeah. Okay. Now don't worry, you see all these problems here, right? I'm not going to make us do all these problems, all right? So don't fret. We're going to do a few together, and then I'll assign a few for homework too, / classwork. Okay? So, solving an inequality is just like solving what other things we've been solving. Solving an inequality is just like solving what other things we've been solving. Yeah, 2-step. Well, inequalities, that's what we're going to solve here. But when we start solving an inequality, we can solve it just like we solve what other kind of things? What other stuff have we been solving in this class? Solving what? Equations. Yeah, that's right. Okay. Solving an inequality is just like solving an equation, except there's an exception here, right? So let's talk about those exceptions in just a second. But first, I want to refresh our memory about the different symbols, okay? Because I know you all know that like the alligator eats like the bigger side and stuff like that, and that's great. That's helpful. But when you see this symbol, okay, when you see this symbol right here, that's great that you know that this side is bigger than this side, right? This side would have to be bigger than this side because the alligator or whatever, the crocodile, whatever you want to say, eats the bigger side, okay? But you also need to be able to read this symbol too. What is this symbol? Is what? Greater than. Is greater than. Okay? This is greater than this, the other side there, okay? Which means then that this symbol means what? Is less than. Now, here's a little trick. If you find yourself, forgetting which one means which one of these looks more like a capital L? This one does, right? And it's less than, okay? So, capital L, less than, okay? That's how you can kind of remember. So, this one is greater than or equal to, right? This one is less than or equal to. This one is greater than. How many can we see? How about this one? Less than or equal to. Again, looks like a capital L. It's got the little equal to sign there, okay? So keep that in mind. Those words are going to be very important that we understand that. And so I'll go ahead and put that here. Greater than or equal to. I'll put it down here. And then less than or equal to. Okay. Now I know you guys have solved inequalities before. Okay? Yes, Tyler.
You divide by like one of the alligator thingies is gonna flip.
Ah, right. So yes, sometimes our signs flip. Do you remember what has to happen in order for the sign in an inequality to flip? Alex? Okay, yes. When we do what with negatives?
Well,
Go ahead,
you
Carson.
did it, you need the less than or equal to, facing the wrong way.
Oh my gosh.
Good catch.
Thank you, Carson. See, you guys are learning right now as teenagers that adults aren't perfect either, right? And it's so disappointing. It's so disappointing sometimes. But that's okay. Anyway, less than or equal to, right. So, right. We were just talking, if we're going to solve an inequality, Alex said it has to do with negatives. What specifically with negatives? When we do what with negatives on both sides? Oh, what was it? What makes us flip our inequality sign around in an inequality? Dividing is one of them. Multiplying. Actually, just dividing and multiplying. I tricked you. So, yeah, only dividing and multiplying by a negative on both sides. Adding, subtracting a negative on both sides, no problem. Okay? And let me just show you like a real quick reason why that is. And please forgive me, guys. I don't want to like baby you here, but let me just show you a real basic inequality. Okay? And just bear with me, all right? Is 2 less than 3? Yes, right? Yes, the alligator is eating the bigger thing right there, right? 3 is bigger, okay? If I add 1 to both sides, right? 2 plus 1, that's 3. 3 plus 1, that's 4. Is this still true? Yep. Yes, right? So if I add the same thing to both sides, the inequality still stays true, right? If I add a negative 1 to both sides, 2 plus negative 1, that's 1. 3 plus negative 1, that's 2. Is it still true now? Yeah, right? Yeah. Okay, and so the same thing will be true for subtraction, because really subtraction can all be changed into addition anyway, right? So addition or subtraction, if you add or subtract the same thing to both sides, the inequality stays true. Now, if I start with 2 less than 3 again, and if I multiply both sides by like 2, let's say, this is 4, this is 6. Is this still true? Oh, so multiplying the same thing on both sides, still true. But now we change it to a times and negative 2, like Alex was pointing out earlier. Okay? 2 times negative 2, negative 4. 3 times negative 2, negative 6. Is negative 4 less than negative 6?
No.
It isn't. Uh-oh. That's why we got to flip that inequality sign around. Okay? When you multiply or divide by a negative number, it changes the truth of your inequality. Okay, so 2 was less than 3, but then when you multiply both sides by negative 2, you have to flip that kind of truth around and say, okay, well now it's greater than, negative 4 is greater than negative 6. That's true for multiplying both sides by negative or dividing both sides by a negative. Okay, so keep that in mind, keep your eye out for that. We didn't have to worry about it for an equation, but think about it. 3 equals 3. Let's say I had to flip the, let's say I still had to flip here. Right, so I'm going to multiply both sides by negative 2. I get negative 6 and negative 6. When you flip an equation around, when you flip an equal sign around, what does it become? When you flip an equal sign around, what does it still become? It's still an equal sign, right? But if you flip an inequality sign around, it changes what it is. It changes from is less than to is greater than. You just flip an equal sign around, it's still equal. So it doesn't matter, okay? So there's no like direction here. If something's equal, it'll still be equal this way too. Okay? Anyway, keep that in mind as we're solving here. All right, we'll do like 1 or 2 together here. So, first person to say it. 1 through 12, which one do you want me to do? 1? All right, we'll do number 1. I was going to do one of the harder ones, but I'll do this easy one, no problem. Okay, 2x plus 4 is greater than or equal to 24. All right, so we want to solve the equation. Well, I'm going to start by subtracting 4 on both sides. That's gone. 2x is greater than or equal to 20. And then the last step will be what? Divide both sides by 2. You got it. X is greater than or equal to 10. Now, the directions are not just solve. What else are we supposed to do now that we solved? Graph its solution. Okay, so you guys remember how to graph the solutions here? Where should I start on my number line? Huh? Do it at 10, right, because that's where our solution is, at 10. What kind of dot should I put at 10?
Open.
An open or a closed one? It's got the equal to. So equal to, does that mean I count the 10 or I don't count the 10? I want to count the 10, so I should put what kind of dot? A closed, a filled in one. Right? Because we want to count the 10. 10 is a solution. Okay? And we want to pick x values that are greater than or equal to 10. Well, which way should I go from 10 to go greater than or equal to 10? Yeah, to the right, right? And you can also test points. Is 11 greater than or equal to 10? Yeah, it is. So we're going to go this way. And there's our answers. Okay, just like that. So what is this? These are all of the solutions on a number line. Okay, now you might be wondering, Mr. Whitmire, we just solved all these equations before this. We never had to graph a solution for an equation. That's because graphing the solution for an equation is kind of boring. The solution to an equation is like x equals 2. So to graph that, you just put a point on 2. And no one's like, okay, it's a point, big whoop. You know, but this shows like all the possible solutions. So 10 is a solution, but so is 11, 12, 13. So is 10.5. So is 11.1. So is 12.9999. You know, so on and so forth. So. All right, pick another one for me. Which one you want? 4. I heard 4 first. 4 is the winner. Okay. So number 4. Here we go. All right. So what should we do here first? Yeah, distribute the negative 4. That's right. So I'm going to go ahead and show that here, and I'll write it out down here. So it's 16. Negative 4 times positive x is negative 4x greater than 56. Okay. I'm going to start getting that x by itself here. So I'm going to subtract 16 on both sides. I'll get negative 4x there is greater than 56 minus 16 is 40. And then the final step, I'm going to run out of space, so I'll do it up here. Final step, divide both sides by what? 4. Ooh, not negative 4. And we should have like alarms going off on our head. Inequality divided by a negative. What should I do to my sign here? Flip it. So it's now, what is the symbol's name? Is less than, or just less than, yeah. And that gives us a negative 10 there. Okay, so we've got our solution. Questions on the solving or anything? Flipping that sign around from is greater than to is less than, because we divided by a negative. Okay, where am I going to start my dot? Negative 10, open or closed? I heard closed and I heard open. What's our symbol here? Does it have equal to? It's not equal to. So should I include the negative 10? If it's not equal to, I should not include it. So open circle. And we would go less than negative 10. Which direction is less than? Ooh, yeah. It's negatives. Be careful here. It's negative 11, negative 12. Those are less than negative 10. So we're going to go this way. Okay. There it is. To the left, to the left. Okay. That's right, Beyonce's favorite inequality. Okay, less than. All right, so there's that. All right, I'm going to give you guys some problems here to work on yourself. So let's take a look here. Let's see. Oh, by the way, I could have divided by negative 4 on both sides first. That would have canceled out with that negative 4, and then we could have done 56 divided by negative 4, and then just added 4. But either way, this is fine what we did right there. Okay, so here's what I'm going to have you do. Let me look at the back here and see how we got these. Okay. I'm going to say, let's just do like 3, 5, 7, 9, 11. Okay, 3, 5, 7, 9, 11. And one more on the back, I'm going to give you 15. Okay, 3, 5, 7, 9, 11, 15. All right, I want you to work on this for the rest of class, and then whenever you don't finish will be your homework. 3, 5, 7, 9, 11, 15. Okay, there's your homework on the inequalities worksheet. Okay. Don't forget to graph your solutions. I will not give you full credit on the homework tomorrow if you don't graph your solutions on the number lines.